All right, so back to where we were. So sequence and series. Series is adding up your sequence numbers. If sequences converge or diverge, what will the sum of the sequence actually do? So if our sequence is -1, 1, -1, 1, if it's finite and ending at a certain point, well, then we'll have different numbers as we go, a different sum, because if you stop it on an even number, you're at 0. If you stop at an odd number, you're at +1 or -1. And then what if our sequence actually converges? So what if it was like the harmonic series, so one harmonic sequence, 1, 1/2, 1/3, 1/4, 1/5, etc., etc. So it's getting closer to 0, so every number that we are adding is smaller, but we are technically still adding numbers, so will our series then be converging or diverging? Gauss's punishment, he had to add together the numbers 1 through 100, and then he realized that 1 plus 100 is 101, 2 plus 99 is 101, and he ended up having 50 pairs that added up to make 101, and the series terms would then be you add up. So if I wanted just the series at 1, that's 1. Series at 2 terms, that's 3. Series at 3 terms, 6. Series at 4 terms, that's 10. If I want the series of what numbers I'm adding, you would just do 1 plus 2 plus 3 plus 4 plus 5, all the way up to 100. So in this case, it is a finite series because we are stopping at 100. The formulas on page 524, you should already have that in your foldable. The bottom left one is S sub n equals n over 2 times a sub 1 plus a sub n. That's the one that we have in our foldable. The other two are perfectly fine. The top is more of just helping refresh on what sigma notation looks like. D, remember, is the constant difference, and we can find that. So if I don't understand the spacing of this PDF, but if you have your series of 1 plus 2 plus 3 plus 4 plus 5, if you do 5 minus 4, then you get your common difference. 4 minus 3 equals the common difference. 3 minus 2. So you're going from the new term to the one previous to find the common difference. So I'm going to start on example 1. I'm going to go back to my worksheet. Example 1, I'm going to type it here, and then I'm going to compile the whole thing so you can watch my typing as well. So a student borrowed $8,000 for college expenses. The loan was to be repaid over a 100-month period. So this is finite. I know it's ending at 100 with monthly payments. Hint, this is an 8-4. We know it's arithmetic, but we can check that. So if I do if I do 119 minus 119.50, well then I'm going to be getting, I know, saving main. Yeah, okay, we're good. Then I get negative 50 cents, and if you look at the whole thing, then you see that there is a pattern of negative 50 cents. So I know that is my common difference. And I'm going to put dollar signs in between there just so it looks fancy. All right. So how much did the student pay over the life of the loan? So I need to make my formula. So I'm going to copy and paste the above formula that we had. That's generic, and then I'll type in the numbers that I need. So I need the first term, which we know is 120. I need the last term, which is 70, 50. And I need to know how many terms that is, which they told me was 100 months. So I am having issues because everybody is online. So waiting for those. Anyway, you can read it in your book too. It tells you it plugged every number into the formula, and we ended up with $9,525. So it was an $8,000 loan. You only paid $9,500 in it. So $1,500 about was your interest. That's not a lot of interest. So I guess it's an eighth, but still. Typically loans are geometric because it's a percentage of your loan. So moving on to example 2, while it's still loading and having issues, and I have no idea how long I have left on this recording. So example